If you look at the part C again, solution D is made up of mixing 100 cm cube 0.1 mole per dm cube propanoic acid, which is a weak acid, and 100 cm cube of 0.1 mole per dm cube NaCl. pH of solution is measured when a small amount of H2SO4 added to it and when small amount of sodium hydroxide added to it. Solution D acts as a buffer when one of this solution is added to it. Complete the sentence and write the equation for this reaction. Now, for the buffer concept, you must understand is CH3, CH2, COOH is a weak acid, and when it is mixed with its salt, then it becomes buffer, not any other salt. इसका अपना salt होना चाहिए. इसके अपने salt से क्या फायदा होगा? Because it is going to provide the conjugate base, this thing. The salt provides conjugate base. Otherwise, if you take the acid alone, its conjugate base is in a very, very small quantity. Although it does ionizes, but you know the weak acid ionization is so small that their conjugate base is almost nothing in their normal solution. So therefore, in order to act the buffer, this acid must have in combination its salt. So acid can neutralize any OH coming, any base comes. So acid का अपना part उसे उसके hydrogen ions उसको neutralize कर लेंगे. But अगर कोई H positive ion आ गया, तो उसको बफर एक्ट करने के लिए, उस H positive ion को न्यूट्रलाइज करने के लिए it needs this base. तो अगर आपने इस वीक एसिड को इस बेस के साथ, इस सॉल्ट के साथ मिक्स नहीं किया, तो इसके पास तो कॉन्जुगेट बेस है ही नहीं. तो इट मींस इट कैन नॉट एक्ट एज अ बफर कंप्लीटली. हाफ वे तो कर सकता है कि ये अगर आप खुद डाल देते हैं तो दिस एसिड कैन एक्ट एज अ बफर बिकॉज इट कैन न्यूट्रलाइज OH नेगेटिव आयंस. But in order to neutralize the H positive ion coming to that solution, it cannot act as a buffer. Therefore, अब देखें sentence क्या कह रहा है. Solution D act as a buffer when sodium hydroxide NaOH is added to it. Why? Because this propanoic acid itself is an acid and reacts with hydroxide ion from sodium hydroxide to form CH3, CH2, COO negative plus H2O. In this way, these OH negative ions that coming to this solution has been utilized and pH is maintained. On the other hand, if you look at this sentence and explain why solution D does not act as a buffer when other solution is added. Solution D does not act as a buffer when H2SO4 is added. Why not? Because in order to neutralize the H2SO4 H positive ion, it needs its conjugate base. So there is no conjugate base of this acid, right? So conjugate base of CH3, CH2, COOH not present in the mixture. Not present in this mixture, right? So it cannot neutralize the incoming H positive ion. जैसे वो नीचे मैंने दिखाया कि ये होना चाहिए था to neutralize this, right? So this is how the buffer works, and if the half part only weak acid has been provided, so buffer not work completely. Although halfway फिर भी react कर जाता है कि weak acid तो आने वाले उसको तो neutralize करता रहेगा alkali को. Okay, next D part. The manganese hydroxide is slightly soluble in water and it's a sparingly soluble compound. The solubility in 3.25 gram per dm cube at 298 Kelvin. Calculate the concentration of saturated solution of this. तो concentration अगर आपको निकालनी है जो कि ग्राम पर डीएम क्यूब में जो दिया हुआ है उसको किससे डिवाइड कर दें उसके mr से, तो वो obviously मोल पर डीएम क्यूब बन जाएगा. So 3.28 times 10 to the power minus 3 divided by manganese hydroxides mr 55 manganese plus 16 plus 1 times 2 80. So 3.28 times 10 to the power minus 3 divided by 89, that gives you 3.69 times 10 to the power minus 5. Now, this is the concentration. Next part, we get the right expression, the KSP expression of manganese hydroxide. You know, KSP expression is always written by using the ions. So, if manganese hydroxide ionizes, it gives two ions, manganese ion and 2 moles of hydroxide ions. Now, put them in KSP expression. So, manganese ion ki concentration, hydroxide ion ki concentration ka square, right? So, and what about the units? This is mole per dm cube into mole per dm cube ka square. So that becomes mole square, mole cube dm minus 9. Okay, use your answer to D1 and D2 to calculate the value of KSP of manganese hydroxide at 298 Kelvin, right? So if you need to calculate the KSP value, so you need to have these values, manganese ion ki or hydroxide ion ki. We have the concentration overall, so we can see the relationship. Ionizes to give what? Manganese ion plus hydroxide ion. So this ratio is 1:1 and this is 1:2. So if this was, in other words, 3.69 times 10 to the power minus 5, so 3.69 times 10 to the power minus 5, Mn2 positive की concentration होगी और इसकी होगी 2 times 3.69 times 10 to the power minus 5. So KSP किसके equal हो जाएगा? KSP is 3.69 times 10 to the power minus 5 into 2 times 3.69 times 10 to the power minus 5. And if we put them all together, so KSP would be, yeah, sorry, KSP क्या होगा finally? What will be the KSP? Minus 13. Yes. So here it is the KSP value, 2 times 10 to the power minus 13. Got it? Okay, next. Question number 4. Look at the question number 4. Define the standard enthalpy change of atomization. It is enthalpy absorbed. It is always endothermic. So it is the enthalpy absorbed when 1 mole of gaseous atom is formed from its respective element. क्योंकि उसने standard का word use नहीं किया, तो we are not writing under the standard conditions. Right? Next. Enthalpy change of electron affinity. It is enthalpy change. Yeah, it is the enthalpy released, as it's the first only, okay? So it is the enthalpy release when 1 mole of electron is added to 1 mole of gaseous atom. 1 mole of gaseous atom. Okay, next. To make 1 mole of negative ion. Okay, explain why the electron affinity of chlorine is more exothermic than the first electron affinity of iodine. If you look at their placements in the periodic table, here is the chlorine and here is the iodine. So down the group atomic radius, yeah, so iodine has a larger or greater atomic radius. So that results what? If it has a greater atomic radius, for example, so the electron is bit away from the nucleus. So there'll be less nuclear attraction, right? So iodine has more atomic radius. जी atomic है ना, first electron affinity है. Radius being down in the group. as compared to chlorine. Hence क्या होगा? Therefore, less nuclear attraction between the nucleus and incoming electron. Right? So hence less energy released. The enthalpy change, D part, the enthalpy change for the reaction of Cl2 plus 2 electron gives us this is minus 486. The electron affinity of chlorine is minus 364. Calculate the enthalpy change of atomization of chlorine. Overall, बच्चों अगर आप इसको देखें Cl2 plus 2 electron, for example, look, if you look at this equation, so Cl2 plus 2 electron gives us 2Cl negative. So in short, the delta H has been given to us, which is minus 486. In short, if you look at this value, so the two phenomena are happening in one step. Which two phenomena? The Cl2 is a gas here. On the other side, it's Cl negative atoms. So it means the bond has also broken. And then chlorine gains electrons. So in the first step, these two chlorine, the molecule of chlorine is going to break and turn into the atoms of chlorine. Right? So it is equal to bond energy or atomization times 2. So I'm going to write it as 2x because it is delta H of atomization of chlorine multiplied by 2 because 2 mole of gaseous atom formed. Then these two gaseous atoms going to gain 2 electron and become what? 2Cl negative. And this is again the first electron affinity of Cl multiplied by 2 because the 2 moles of chlorine atoms. So this is, so now if you look at the data, we have this value minus 364 times 2. We need to find this value. So I'm going to write it as 2x. And we have this value minus 486. So it means we can make a Hess cycle. Delta H, which is the direct enthalpy, this one, is equal to, if you add them up, the step 1 and step 2 enthalpies. This is step 1, this is step 2. Step 1 enthalpy is 2x at this moment, 2 times of delta H of atomization. And the step 2's enthalpy is minus 364 times 2. So अगर delta H की value डाल दें, minus 486 is equal to 2x minus 728. So now 2x is equal to 728 minus 486 is equal to, sorry, 240 plus 242 kilojoule per mole. So x would be equal to what? Plus 121 kilojoule per mole. And this is the x is here, delta H of atomization of chlorine, right? So this is what we were looking for. And this value is plus 121 kilojoule per mole, right? So this is how we find out this atomization for. Next